Have you ever felt like there's a hidden pattern to the universe? Some kind of underlying logic that connects, I don't know, music, art, and even the laws of physics? Well, it turns out there is. It's called group theory, and we're about to pull back the curtain on this amazing idea.
I know. That sounds like the beginning of a really weird joke, right? But believe it or not, there's a real solid answer that links all of these things together. And by the end of this, you're going to know exactly what that secret ingredient is.
So, to understand this huge cosmic idea, our journey actually starts somewhere, well, somewhere surprisingly simple. It starts with the basic rules of math that we all picked up back in grade school. Remember the commutative law? It's just that simple idea that 6 plus 3 is the exact same thing as 3 plus 6. Same for multiplication. 2 times 4 gives you the same answer as 4 times 2. The order just doesn't matter. It's one of those rules that's so basic we kind of forget it's even there. And here's a cool little tidbit. The name commutative actually comes from the word commuter. Someone who travels back and forth from home to work. Just like a commuter can go either way on their route, numbers can swap places and you still end up at the same destination. It's a neat little way to remember it. Then you've got the associative law. This one just says it doesn't matter how you group the numbers. So if you're adding 2 plus 4 and then add 5, you get the same thing as adding 4 plus 5 first and then adding the 2. You get 11 either way. These rules, they're like the first clues to a much bigger mystery. Okay, so to build on this, we're going to need two key ingredients. In the math world, they're called a set and an operation. Let's start with a set. And hey, don't let the technical term throw you. A set is literally just a collection of things. That's it. And the things inside the collection, we just call those elements. Super straightforward. And a set doesn't have to be numbers. It could be a collection of clothes in your drawer, like socks, shoes, and pants. It's just a way of saying, here's a bunch of stuff that belongs together. So if a set is the collection of stuff, an operation is the action you do with that stuff. It's just a rule for how to combine any two elements from your set to make a new one. A really great way to picture this is like a machine. You take two things from your set, pop them into the machine, it whirs and clanks for a second and spits out a single result. Addition and multiplication, they're just operations. They're just the machines we use to combine numbers. Okay, so we have our sets and we have our operations. Now we get to put them together. And when we do, we can form something called a group. This is where it all starts to get really interesting. So, a group is just a set paired with an operation. For instance, the set of all integers paired with the operation of addition. But, and this is the important part, to officially be called a group, this combo has to play by 4 very specific rules. And here they are, the 4 rules of the club. Closure, associativity, and an identity element and an inverse element. If your set and operation can check off all 4 of these boxes, then congratulations, you've got yourself a group. The first rule is closure. I love this analogy. Imagine your set is a completely sealed box. Closure means that if you reach in, grab any two things, and combine them with your operation, the result has to also be inside that same box. You can never create something that's outside the original set. All right, the next 2 rules, identity and inverse, are kind of like a buddy system. The identity is like a neutral element. For addition, that's 0, right? Because adding 0 doesn't change anything. And the inverse rule says that for every single element, there has to be an opposite that gets you back to that neutral identity. So for 5, the inverse is -5, because 5 plus -5 gets you back to 0. Okay, now for the big reveal. Let's take the set of all integers. If we pair it with addition, is it a group? Yep, it follows all 4 rules. But what if we pair those same integers with multiplication? You'd think it would be, but get this, the answer is no. Let's dig into why. So let's run down the checklist. Closure? Pass. An integer times an integer is always another integer. Associativity? Pass. That works too. Is there an identity? Yep, it's the number 1, because anything times 1 is itself. But inverse? Fail. This is where it all falls apart. Think about the number 5. To get back to the identity, 1, you'd have to multiply by 1/5. But 1/5 is not an integer. It's outside our closed box. And because that one rule is broken, the integers with multiplication do not form a group. At this point, you might be thinking, okay, that's a cool little math puzzle, but why does this matter? Well, this is the payoff. This is where this abstract idea suddenly becomes one of the most powerful tools in science and technology.
See, once you know that something forms a group, you unlock this whole predictive toolkit. Group theory is used in chemistry to understand how molecules behave. It's used to fix errors in the data we get from space probes. It's even part of the system that checks if your credit card number was scanned correctly. It's this hidden engine running behind so much of our world.
And it gets even more profound. I mean, check out this quote from Access Science. In modern physics, looking for these underlying group structures, these hidden symmetries, is one of the main ways scientists come up with brand new laws of the universe. It's literally a guide to understanding reality itself. So think about that. We started with something as simple as 3 plus 6 equals 6 plus 3, and we ended up at the fundamental laws of physics. It shows that if you can just define a few simple, elegant rules, you can uncover these incredible hidden structures that connect everything. And it just leaves you with this one big question. What other amazing, powerful structures are out there, just waiting for us to find the right set of rules to see them?